Welcome students. This is a lecture on limits. We are working on trigonometric limits. And see here in this question what I have to evaluate limit x tends to 0, x tan x over 1 minus cos x. And we all know what does it mean. We have to get when x is approaching 0, we have to find what number does this approach. So see here, we will first find it out. Okay, evaluating a limit problem, we all know what does it mean. If somebody asks me evaluate this limit problem, so what basically they're asking me that variable x is approaching 0. So when the variable x is approaching 0, what number is this f of x approaching? So I notice that when x is approaching 0, so this is going 0, right? So this x is approaching 0. This x is approaching 0. Here I have tan of x. So angle x is approaching 0. So it means this is approaching tan of 0, right? What is tan of 0? 0. And just before that, as a factor, I have one more 0. What is 0 into 0? 0. The numerator is approaching 0. Look at the denominator. In the denominator, I have 1 minus cos x. What is x approaching? X is approaching 0. This angle. So cos of 0. This is approaching cos of 0. What is cos of 0? Yeah, tell me, Sanvi, what is cos of 0?
1.
1. So this is 1 minus 1. So it is going where? 0. So you got 0 by 0. I hope you understand. So what do I do? Now listen, students, what do we do? In order to see, we got the answer as 0 by 0. Now we all have to understand that this cannot be the answer because 0 by 0 is no number. It's an indeterminate form. So in order to evaluate, there are two ways. Either I cancel the factor responsible for 0. Either I cancel the factor responsible for 0, okay, or I use the result. So here, see, canceling factor will not happen. Instead, we'll have to use the result. Now, what are the results that we have? If you remember, students, see, we have following results. Sine of theta, here it is x. So sine of x upon x, when x tends to 0, the limit is equal to 1. When x tends to 0, the limit is 1. And the same thing we have in tan also. Okay. Another one that we have is limit tan of x upon x, when x tends to 0, the limit is 1. Now see, what I understand is, everybody watch. See, I have here tan of x, but I need 1x in its denominator. See, try to understand. This is going 0. Is this approaching 0? Yes. Is tan of x approaching 0? Yes. Okay, when x is approaching 0, tan of x is approaching 0. See, how do I manage to resolve this? See, the next step, first of all, I write here, limit x tends to 0. Okay, this is very important question. See, x into tan of x upon 1 minus cos. You remember that special formula, all of you, 1 minus cos? Dear students, we are going to use the special formula. These two are very important formula. If you do not know, please write it. And keep writing till you know this. Keep writing till you know this. You just cannot forget. You cannot risk forgetting these formulae. 1 minus cos is 2 sine square, half the angle. I have said this thousands of times. See, 1 plus cos, you write 2 cos square, and whatever angle you have, you write half of that. So see here, it is 1 minus cos. I will write 2 sine square x by 2. Okay. Now see, the next step that I do is a major step. See, students, I write, since x tends to 0, x is not equal to 0, x square is not equal to 0. Since x tends to 0, x is not equal to 0, x square is not equal to 0. Okay. Since x tends to 0, x is not equal to 0, x square is not equal to 0. Therefore, dividing numerator and denominator by, x square. See, I divide numerator and denominator by x square. So I get L is equal to limit x tends to 0, I get x tan x upon x square. Okay. See, and 2 sine square x by 2 upon x square. You can ask me, sir, how did you know that we have to divide by x square? It's very simple. Because I had here sine square. You see, I have sine square. I understand the result demands. What does the result demand? It demands sine of x upon x, and x tends to 0. You see this? Sine of x upon x, x tends to 0, the limit is 1. If I have one single sine, then I would need one x. If I have one single sine, then I would need x. So here what I have here sine square. So I would need x square. So that I can write common square sine x upon x the whole square. So that in the next step I can write sine of x upon x, and then I can write the common square. I can write the common square. So if you have sine square, you have to divide by x square. Moreover, what you notice is when you are dividing by x square, you also divide the numerator by x square. And there also what you notice is that here you got x and this is x square. So one x cancels, you are left with tan x upon x. So see, the next step I have, see, I write common square here. So this is L equals to limit x tends to 0, and then I have tan x upon x. And here I have, see, I have here 2 and sine of x by 2 upon x the whole square. Sine of x by 2 upon x the whole square. I write separate limit for this and limit here. So I have L is equal to limit x tends to 0, tan of x upon x, and this I write limit here also, 2, limit x tends to 0, sine of x by 2 upon x the whole square. Okay, now see, this is going to get me 1, and here what is going to happen, students? See, this is sine of x by 2. You know the result says whatever angle, if you know the result, there are conditions to be satisfied in order to use those results. What was the condition? If you have sine of some angle here, the denominator should have same angle. Okay, so if I have here the angle is x by 2, if I have x by 2, I should have x by 2. Okay, so here what I notice that here I got x by 2, but this is not x by 2. So what I will divide? I will write here divide by 2. See, I divided by 2. So this divided by 2 you did, so you'll have to multiply by 2. Okay, check this out. Check this out. See, you divided by 2 only to have the same angle in the denominator. You have x here. So you divide it by 2, you multiply by 2. Okay. Now you can use the result. I will write here as x tends to 0. I write here as x tends to 0, x by 2 tends to 0. Therefore, using limit sine theta upon theta equals to 1, when theta tends to 0, we get what we get. And one more result we are using. Limit tan theta upon theta when theta tends to 0 is 1. So see, students, we are going to have 1 here. See, we are going to have 1 here. And we are going to have this part as 1. You can check, see here. This much is 1. Not this 2. Okay, this 2 is outside. So see, the next step that I have is L equals to 1 upon this 2 is outside, 2, then 1 into 1 upon 2, this 2 here, 1 upon 2 here. You see this? 1 into 1 upon 2, the whole square. So this is L is equal to 1 upon 2 into 1 by 4. The answer is 2. Answer is 2.